Well, welcome everyone to the webinar. It is the top of the hour and I'm going to just take care of a few housekeeping details. I think we have plenty of people joining all at the moment, so I'll just take care of that. Tell you a little bit about the Science Gateways Community Institute and hand it off to our presenter today. So my name is Catherine Lawrence. I focus on community engagement here at the Science Gateways Community Institute. And I first want to just give you a few housekeeping details. We would like you to keep your audio and video both muted during this presentation. That should be the case when you join. And then, however, a little bit different than our usual procedures. We would like you to submit your questions using chat, and you can do that at any time. Marlon Pierce will be presenting the majority of this webinar, and he has said he's happy to answer questions at any time. So if you have a question, I'll be keeping an eye out for those, and then I'll interrupt him, and you can unmute yourself once you've been sort of identified as having a question, and you can tell him your question yourself instead of my reading it to him. So he's happy to talk one-on-one with you that way, but that way at least we'll not all be asking questions at the same time. This is being recorded, and the slides and the presentation will be on our website, as always, in our webinar archive. You can pretty much bet that it will be up there within a day or two after today. So the next thing I would like to do is tell you a little bit about the Science Gateways Community Institute. We offer services in support of the Science Gateway community in three major areas. Our first area is providing support for building and running gateways, and that includes hands-on development support, which is up to a quarter of a person's time on your project for anywhere from 3 to 12 months or 6 to 12 months, something like that. That is the area that is overseen by Marlon Pierce, who will be speaking today. We also have other consultants who can provide advice about things like cybersecurity, usability, graphic design, business planning, sustainability, and so forth. And then finally, we have a catalog of gateways and software where you can list your gateway so that it'll be more easily found by people who might be looking for either a gateway to use or an example of something that does what they would like to create. And we also have software listed, so it's a great way to find out software such as this platform. And this is, as we mentioned in our advertising, this is part 3 of a series about all different gateway platforms. So this and many other platforms are listed in the software catalog, part of the catalog. Our second area of support is through education and training. Obviously, this webinar series falls under that. We also have a 5-day program called Gateway Focus Week, which allows small teams of gateway developers to spend an intensive chunk of time looking at everything from who they serve, what niche they fill, and how they plan on becoming sustainable. The sort of a big picture look, diving into the different aspects that are crucial to helping your gateway succeed. We have a variety of student-focused programs. You may have noticed on our first slide that we currently have student programs getting into gear. That includes a coding institute, which will be virtual this summer. It's 4 weeks. And we also have a internship program. We're hoping to find sites that are willing to host an intern virtually as well. We're looking for that right now, both students and host sites. And we also will be having a hackathon as in conjunction with the PERC conference, and that will also be arranged as virtual this year. So those are programs that are in percolation right now, and I encourage you to look into the internship and coding institute for students that you have, or if you'd like to work with a student. And our website, of course, has a variety of resources and materials we encourage you to view. And then finally, a third aspect is networking and community. And as part of that, we have our annual conference. Currently, our call for participation is open, and the deadlines are in mid-April a little bit, later in Oh, I've lost track now. Anyway, we have extended our deadline for the tutorials and workshops, but it is a little bit ahead of when the papers are due and also panels and demos. And that we are, just so you know, we're making plans so that if this whole COVID thing gets in the way, we will still have ways of making it an opportunity to share and get your information published through the proceedings and so forth. So we encourage you to still submit to that, which is not a huge hurdle. The longest you'd have to write is 4 pages. Our community forum is a Google group that you can join to connect with other people and ask questions. And we also have some ambassadors programs, and affiliates and a partner program, which you can find out more about on our website. And do let us know if you have news or jobs that you'd like to post. So with that, I'm going to hand this off in a moment, but at the end of this, I do hope that you will take a moment to give us feedback. This is one way that not only do we demonstrate to the NSF that we're doing something valuable, but also we use it as a way of getting ideas for series or presentations during this webinar series. And in fact, this set of sessions focused on gateway platforms came right out of people asking for interest, being interested in learning about a variety of platforms for building gateways. So with that, I'm going to stop sharing my screen and let Marlon take over. Marlon Pierce is one of my colleagues here at the Science Gateways Community Institute. He also is supervises the Gateway Development Area at Indiana University's Pervasive Technology Institute, and which I know has been renamed, so I will let him tell you more about that. He is also going to be supported during his presentation by his colleagues Suresh, Marru, and Marcus Christie, who will pipe up with additional comments and information as needed. So with that, Marlon, would you like to take it on?
Sure. Yeah, so I'll have my camera off most of the time, but I want to go ahead and turn it on, say hi to everyone. Thanks for calling in, joining us. I hope you're all doing well in these unusual times. And let's see, hope my sound is okay.
Yeah, your sound is good.
Great, all right. So let's get going then. All right, so thanks, Catherine, for the introduction. And as Catherine mentioned, some of you have interacted with me through my role as director or leader of the extended developer support component of SGCI, but also I'm the director of the Center for, or the Cyberinfrastructure Integration Research Center, I should say, here at IU, and I'm going to tell you about stuff that we do here to support Science Gateways. So, title of the talk is, of course, Building Science Gateways with Apache Airavata and SciGaP Services. I have a chat message already.
Oh no, I just let people know they can put their questions in.
So, yeah, and I want you all to understand I'm going to be talking for presenting the work of our team, and so I want to acknowledge everyone here who's done so much to do everything that I'm going to be talking about. So Suresh is the architect of most of all of the things you're going to be looking at. Marcus, Aroma, Isuru, and Demuthu are all leading subcomponents that will the project that we'll look at in some detail later. So a quick acknowledgement, work is funded by various funding agencies and also grants from our collaborators. So as I mentioned, I'm the director of the Cyberinfrastructure Integration Research Center here at PTI. And so we have the staff pictures here. I'll assure you, these are all very recent photos of all of us. And we take, especially me, so we take a full stack approach to Science Gateway cyber infrastructure. So we develop innovative open source Science Gateway software. We operate gateways for our clients. We integrate with campus resources. We collaborate with scientists, and we teach applied distributed systems. So probably everyone on the call, or most likely most of you, are familiar with science gateways, but I want to go ahead and give a bit of a definition for the record, and also in case you're wanting to come up to speed. So science gateways, I think, can be viewed as cyber infrastructure that supports fair science. So that's findable, accessible, interoperable, and reusable. And so there's a paper that several of us in the community co-wrote for the International Workshop on Science Gateways a couple of years ago, where we explore these ideas. So, you know, a lot of it is born out of this idea of, oh, I want to have a gateway, I want to have a user interface to a supercomputing center or something like that. But really, we're trying to step back and see what are the abstractions that we're really talking about. So some of the key features of science gateways are that they manage users' identities, which is sort of a prerequisite for us. And then when you use a gateway, you're maybe running some software, you're moving data, you're doing something, doing some analysis steps or something. We in Airavata refer to those as computational experiments. And so gateways need to record those experiments that you do and store them as digital objects. So then once you have these digital objects, you can save and reuse them and organize them and so forth. And then you can also share them with collaborators. So Apache Airavata is our team's implementation of those ideas. So for gateway developers, you should know that Airavata is open source software. It's a top level Apache Software Foundation project. If you're a gateway user, what do you do with it? Kind of the core of it is you can use it to transfer data and execute remote applications and pipelines on distributed resources. So as we'll say in a minute, you don't need something on Airavata to be installed on a particular machine for it to work. We can talk to and pull together lots of resources that are specific to your problem. But also, if you're scientific teams, in the process of using this and creating these digital objects, you create, organize, and clone and share these computational experiments with each other. And then finally, if you're a scientific software provider, you can think of this as a gateway in general, and Airavata as a great way to deliver your software, put it into the hands of people without having them, worrying about how to get things installed locally and futzing around with versions and dependencies and so forth. You can deliver it as a service. So we run Airavata. Airavata is, again, the Apache Software Foundation top-level project. It's got members outside of our group. But at CIRC, we run Airavata as a platform, and we call that SciGaP. So it's Science Gateways Platform as a Service. So you can see some numbers. We have currently 40 registered gateways using the platform, 118 applications, 50 resources, and so forth. So if you look at it, peel back the hood a little bit and say, what does this thing look like? What are the components? You'll get this picture. So let me walk you through this a little bit. On the left-hand side are all the gateways. And so Airavata is designed to be multi-tenanted. So if you have a gateway and you're using our hosted service, we don't need to spin up another instance of the middleware for you. God help us, we don't have to maintain a separate version for you, but rather we have one version. Sorry. We have one version that supports all those gateway clients, all those tenants. And they all come in through this API server. So these tenants, we'll show a few examples, and some of our collaborators are on the call here, but they could be computational chemistry or biophysics or bioinformatics or other engineering applications. And we have digital librarians building gateways and many diverse types of clients. So we're not geared towards any specific scientific domain. So these gateways go through an API server. We use an interface definition language called Thrift that gives us an ability to support lots of different languages and to provide some what we feel are important advantages over using REST. There are some other alternative API approaches that we're also investigating. I'll say a little bit more in a minute. The user management subsystem will have a, this is how you authenticate and manage your access to different applications and so forth. The execution subsystem down here at the bottom is what most people might think of with or a lot of people might think of with a gateway or Airavata gateway. It's an execution engine that runs your codes or your pipelines on target resources, but also there's other components. An orchestrator is a piece that helps define different pipelines and define how you want something to be executed. So the minimal version of this is stage data into a resource, run one or more applications on the resource, stage data off the resource. And then there's a metadata description of all the applications that are installed. And then the data subsystem, which is undergoing some significant enhancements, I'll talk about in the last part of this presentation, is used for, among other things, moving data between different endpoints. So user's desktop, uploaded through a browser or another location, and get that staged to an execution host for execution, and then stage it off back to the user, to an archive, all those types of scenarios. Embedded in this also is this thing called an experiment metadata catalog that I mentioned. The idea here again is that you're not just using this to move data. You're not just moving, or you're not just executing codes. You know, this is not Slurm on the web, but rather we're capturing your experiments and storing that metadata and adding additional values of service like ability to share and things like that on top of those capabilities. And then the far right here is all the computational resources, if you will. So Airavata does not need anything installed on the target host. And if you're using the SciGaP services, we run all these things on highly available stable virtual machine infrastructure at IU. I'm not going to talk in length about the execution engine because we have a whole paper and presentation at PERC19 that Demuthu from our team led and goes into great detail about what we did. And I hope you, if you're interested, we'll look at more into this and the capabilities of how we're using Apache Helix. I will say that this is an example of something that we do a lot of, which is we're constantly looking for how to upgrade Airavata. So 15 years ago, when we started, or more years ago, with earlier great-great-great-grandfather versions of this software for the lead project, you know, back in those days, you built everything, you wrote everything yourself. You have 10 components, you need 10 grad students, or maybe 20 components and 10 grad students or something like that. But over time, you know, it's been completely all replaced. And when we find a new component by somebody else that does something that we do, but you know, does it better, we'll gladly replace it. So there's an execution subsystem called GFAC, historically in Airavata, or I call it GFAC, went by various names. But we eventually found this nice replacement, which I'll say also came out of work that was done by some very good students who came through a class that we teach. But they laid the foundation for this use of Helix. We're happy to use a third-party piece of software and think more and more about Airavata as this thing that sits on top of a foundation and is used for integration. So Suresh and others have used this metaphor of, replacing the jet engine on the plane while it's in flight. So that's how modern software as a service or platform services run. And so that's the model we try and follow. So when we find, let's say, a component for that's better than we can do on managing user identities, there is. It's called Keycloak, and there's a wonderful service from Jim Basney called CI Logon. Then we don't have to build those things. We integrate those things, and we're always looking at making these upgrades to the system where we're replacing parts and hopefully providing more and more capabilities with it, while also keeping SciGaP running in production. So that's an overview of Airavata. So one of the trends that we've been following, or I should say retrospectively, it's a trend that we see, is that it's good to kind of start to add on and decouple and make things, parts of the system, available, or to supplement the basic Airavata system with other components. And so I want to spend the rest of the presentation here talking about three major new things that we've been doing over the last year or so, a couple of years. So the first thing is the Airavata Django Portal, and this is led by Marcus Christie in our group. And so this is an out-of-the-box Airavata Gateway user interface that is also extensively customizable. So these 4 screenshots here are for 4 different gateways. On the left, we have searching SRA, and then the atomic and molecular physics gateways for respectively bioinformatics and physics, the physics community. These are kind of out-of-the-box versions of the Django Gateway, but they've been customized. Their look and feel customized. So it's the same thing under the hood. The 2 other gateways here would have maps. The one in the middle here, upper middle, is a gateway called Interactwell, which is a food, energy, water NSF funded or infused NSF funded project. We're looking at how civil engineers can work with sustainability managers and farmers and other people in Oregon to manage water resources, to use modeling, but also to help decision making. And then the gateway here on the upper right is a screenshot from SimCCS, which is CCS is carbon capture and sequestration. This is with Kevin Ellett here at IU, at Indiana Geological and Water Survey. So this is a similar thing in that there's a simulation code developed by DOE researchers at Los Alamos for simulating how to do carbon capture from power plants and store it. And so CCS is or SimCCS is a software package for finding the right strategies for using your infrastructure to store that all that carbon being generated. But so it's not just for scientists; it's for policy or decision makers. So they were, before all the COVID-19 crisis, for example, the SimCCS developers at Los Alamos were meeting with government officials, several Senate aides, and so forth, because this is before COVID-19 changed of all of our priorities. Reducing carbon emissions is an important long-term thing we need to do to avoid a long-term economic or long-term environmental and economic disaster. So these last 2 gateways are also built on Django, but they're extensively customized over the top of this compared to the basic framework. So the Django portal for Airavata, you need to remember Airavata is middleware, has a nice API, and you can program to that API. But we realized early on in the project we needed to illustrate all the API. And we realized later that that illustration itself needs to be more than just a reference implementation to show you a demo, but rather be a full-fledged thing that can be used to support production gateways. So the Django Portal for Airavata is basically the default gateway interface. It's not the only way of doing it. You can integrate your gateway through the API, and we also have an effort for a couple of projects at least, to provide Python SDKs a little bit more than what you get from Thrift auto generation to help them integrate with other types of clients. But for the vast majority of the people we work with, Django is the thing. And so this is a high-level picture of it. So just to name check a few technologies, it's, as I already said, Django in the middle. That's the web server that talks to Airavata through the client API, and then all the front end parts are leveraging Vue.js for creating dynamic web experiences. So if you use it out of the box, you can get, this is an example from a sample gateway called Chest Drive that we run. If you use it out of the box, it will generate a bunch of user interfaces based on your configurations. So you don't have to program anything. So all your applications, these are a bunch of mostly chemistry applications for illustration, but all your applications for a regular user show up in these panels. And we worked with our local usability and user experience team here at IU to help us put all these things together. So based on how you configure the system, web forms will get generated, and they'll help you, and they're pretty flexible, and they'll help you create input forms that are appropriate for your application. And so a user can come in and create, this is not all the screen, this is a fairly simple interface here for this particular application. Gaussian, there's more to say about that, but this is, again, in our terms, creating this experiment digital object. So when you fill out the form information is stored for you, and you can come back later and review it, clone it, organize it into projects, share it with people, and so forth. You can browse all of your experiments. If you're an administrator, there's also a pretty extensive set of user interfaces that I won't show you all of them, just give you a couple of things. So here is from SGRID, which is a chemistry gateway that we run that's pretty much using the off-the-shelf version of Django. And so here's some experiments and statuses. So it's always good, for example, to know if things have failed or if there are any problems with the system. So there's some interfaces for looking at that. And then also there are interfaces for configuring applications. So the forms that get generated, let's say for this application Abacus, the forms that get generated are based on stuff that an administrator fills out to describe how the code should be run and how it should be run on a particular host, like say Comet. So it looks like a chat question. Yeah, okay.
No, just reminding people to do the, don't worry, I'll let you know if there's anything important.
Okay, so that's fine. Okay, so yeah, so Django is fine. So you can use things pretty much out of the box, and you can create a sample gateway, of course, but now you'd want to customize it. So we have several levels of customization that you can follow. The first level is to change the look and feel and a few other things like this. And so we use a piece of software, open source software called Wagtail, which is a content management system that plugs into Django that allows you to do all this. And so you can customize your gateway without us having to do it for you. And say this also was a student project that from a class that we teach at IU that had a particularly good outcome, that the student did a really thorough job of evaluating solutions for this problem and recommended this and then helped us implement it. The next level is you can customize the input and output editors that are generated in the web forms. And so this is an example of how you could take on the left a standard input type and replace it with radio buttons, checkboxes, etc. And you can also add validation. So, minimal, you can make some changes here with some minimal coding. And you can also customize, I'll flip through these, you can customize the output views. So you can, with some coding with your own local copy of the Django Portal, you can, this is a little bit more than what somebody would do with Wagtail, but you can, with a little bit of effort, add plotting features and charts, other types, images, and so forth that you might want to display. And I should say both of those things were reviewed, and they're pretty well extensively documented on our link I'll give in a minute, and those were featured in the Gateways 2019 tutorial. We'll probably be doing an updated version of this, travel willing, for Gateways, and reviewers willing, not to compare reviewers with COVID-19, but we'll do this in Gateways 2020. And then the last is level of customization is that you can write an entire custom Django app. So some gateways don't really fall into this, I'm going to run an application thing type of scenario, but like I mentioned earlier, SimCCS or InteractWell or other gateways should be extensively customized because they have a wide range of people who will use the gateway. So in both of those cases, those users don't just include scientists running simulations, but also decision makers, or local officials, or other people, or even in the case of InteractWell, the private citizens. So our approach to do this is to support the use of Django apps. I would say to date, these are things that we typically do through funded collaborations with people. So more info about Django. Check my time here. We run the Django portal for most of the gateways, most of the clients that we work with. Some run their own versions, but most of them are also part of the SciGaP hosting. You can go and play with the code here in GitHub. It's all open source, and like Airavata middleware itself, it's all like Apache licensed. And there's some nice documentation with lots of examples on how to use Wagtail and how to make extensions and so forth. Okay, the next project is called Custos, and it's Science Gateway Security as a Service. And this is an NSF award that we won with Jim Basney from CI Logon and Enes Afghan from the Galaxy team. And the idea here, the core idea, was that in Airavata we have all of these capabilities I'm describing, but there's a subset of things that people need to do for security. So not every gateway is there to run a job on a supercomputer. And some gateways like Galaxy already do that quite well. So, but they have security, they have, they'd like to think about how do we evolve our security systems. So we got together and got this proposal funded. And so I'm going to tell you a little bit about this. So again, the key idea was a lot of this software has an earlier form in Apache Airavata, but in the process of doing this work, it's given us a chance to really rethink how we build our software. So the main capabilities of Custos are summarized in this table. It's a The first thing is a tenant profile management service. So a tenant here means a gateway tenant. If you have a gateway, then you would use this part of the API to create a tenant in the system. The second part is identity and access management. So this is, if you have a gateway, you are the tenant and you have users of your gateway, users of your tenant. So the second part here allows the gateway administrators to manage authentication and accounts of their tenants. And so this is leveraging heavily the Keycloak software, very actively developed piece of open source software, and then also CI Logon, which is open source, but also a nice service for federated authentication that Jim Basney and his team operate. The third component of the Custos system is secrets management. So in Airavata, if you remember the picture a little bit ago, there's middleware, and then that, say, runs at IU, or you could run, if you're a developer, you might be running your own local copy of it, but you connect to remote resources. And so the way you do this is, of course, with secrets. That might be credentials of various sorts. It might be OAuth 2 access tokens or other types of web tokens, API keys, things like this. Sci tokens is another of Jim Basney's projects. So these secrets are housed in the middleware. There's a thing in Airavata called the credential store that does this, but again, changing out the part of the airplane as it's in flight, we found that HashiCorp, which many of you are probably familiar with, has a nice piece of software called Vault that does what Credential Store does, but better and in a modern way. And so we replaced the Credential Store with Vault for secrets management. But so we're building on, Vault is kind of down in the stack. It's not something that's directly visible to the Custos user. And finally, there's groups of sharing management service. So this is the part of Airavata I already mentioned, that where you can share experiments, share digital objects. So this is also part of the Custos stack. So this is a way to create groups to share things among group members and so forth. This is one case where we looked at a bunch of other third-party systems, particularly Grouper, and found that they didn't really work for what gateways needed to do as we needed it. And so we actually still keep that part of the software ourselves in our development, in our source code.
And Marlon, so, before you carry on, a quick question that just occurred to me, and this may be something obvious to more technical folks in your audience, but when you referred to tenants, you mentioned that the gateway itself is a tenant, and then in the second row of your table in the previous slide, you mentioned that the gateway can then manage its tenants. So is it assumed that there are levels of tenants? So then it's sort of like subleases or something like that?
No, here tenant means the gateway, and then it manages the users of the gateway. But so that, I think tenant there is a little bit ambiguous, but it's referring to the client.
So it's still referring to the gateway itself. Okay.
So Mona has a question about, which is, does Custos have role-based authorization? So I'll kick that one out to Suresh, if you're online, if you could unmute, you want to handle that one?
Yeah, hi Mona, can you hear me okay?
We can. Mm-hmm.
Okay, yeah. So yes, Mona, in a couple of ways. So basically, the role-based Custos provides authorizations. Like, the implementation, we've been switching from between role and group on how you apply. The role-based are typically applied for API methods, and you do group-based authorization for the resources like compute resources. You have an experiment to share there we are trying to do group-based authorizations, and role-based are for API methods.
Thank you.
Yeah. Okay.
Mm-hmm.
Thanks for the question.
Sure.
Other questions while we're at it?
Nothing's popped up on chat, but I'll let you know if anything does.
Okay. So here's a diagram to illustrate some of these things. So the custos components are in the blue box in the middle here, and I've kind of already, I think, gone over them. They're accessed through an API, and then different gateways can work with those APIs. So Airavata here, if you will, this box is a bunch of boxes that is that system I showed earlier. Galaxy is also our partner on this project, and they're integrating it with the Galaxy framework, and then also our peers in the Pervasive Technology Institute, the HUBzero Research Center, were looking at a lot of the same software stack and saw that we had what they wanted, and so we're working with them to also be a custos client. So hopefully that one will be done in early summer, and they'll be using it. So the project's got a couple of years under its belt, and we're getting close to making it something that is available for a broader audience. But we're going to serve well our 3 drivers down here at the bottom first. Make sure that we're doing that. I'll add also, we fund in the project the Center for Applied Cybersecurity Research to help us review architecture, implementation, and operation. So so that's also an important part of the project. This is a little bit of a look into under the hood, and so one of the side effects, not necessarily intended from the beginning, but what we found was really a nice thing here, is that we could not just, pull out our software from GitHub and bundle it all and call that done, but rather let's fundamentally look at all of the stuff that we do and think about not just the code itself, but the operational environment. So one of the important trends, or some of the important trends in our world, are microservice architectures, Kubernetes, and service meshes. And so what we're doing is, with Custos, we have an opportunity to build from scratch some of these, to build up again the system and use some these modern approaches of running distributed systems. And I would say also gRPC is a thing that we're looking at as an interface definition language that we may potentially use throughout the Airavata project. So the nice thing about that is that we don't tell people the API, but rather, it's open, but rather we give people SDKs, and so we can. So you essentially have an SDK that you program against for your programming language that's also going to capture the data types that you're communicating. So anyway, I'll move along. So the last major new thing in Airavata is this is led by Dimuthu Wanapuraj. Asura Ranawaka was the primary implementer of all the Custos stuff that I was showing you. The last thing is managed file transfer. So this is data movement for science gateways. So Airavata today is kind of the top half of this figure, everything above this black arrow, in which we had some assumptions that eventually were becoming technical debt in our project. So the assumption is that gateway traffic tends to flow, if you will, uphill and downhill. It flows uphill from if you could change the directions if you want, but uphill from the web browser or the desktop to where a user provides an input file to the remote resource, and then download it again, download the output. the output gets staged back to the gateway. But these aren't really, this isn't really the case. So the MFT is a new component of Airavata that can be used by itself, but also it can use Airavata as the controller where the data movement is implemented outside of Airavata. So one of the drawbacks, I would say, of our shared nothing architecture that I showed at the beginning, where Airavata, you can run Airavata on a set of servers and then don't need anything installed on the back end. It does impose some limits, and so the MFT is a little bit different thing for us because it has agents that can be installed on target resources. Also, it supports existing. We needed to support existing file transfer protocols, a diversity of those. Implement something where you have it separated out from the code base, and you can start to think about and implement in a way that may be easier to get your head around how to handle fault tolerance and scalability of this one component without having to think about how all that works across the entire system. So in short, it looks like this as an API, which Airavata, other parts of Airavata can use, or also can be used by other gateways. Integrating LAD with Custos is something that is on our roadmap. And so these agents can run at various locations, including on a target resource. And they use a protocol called tusk, which is a resumable file transfer protocol from HTTP to handle some of these file transfers. So there are a few different modes of use. The simplest one is basically what we do now, one-to-one transfer. You can do replication where the data might get pushed into multiple places. Affinity transfers and network optimization transfers. So a couple of cases here are sometimes you have to use a particular path, or other times let's say if it's sensitive data that can't leave a particular target resource, then but you need to transfer it locally, then those are another use case that MFT is supporting. Okay, so some key points for the presentation as a whole. Apache Airavata is open source and it's open community software. The team here, CIRC at IU, is the center. The Cyberinfrastructure Integration Research Center, and we run Apache Airavata for clients on a platform called SciGaP. You can still take Airavata and use it. I would say that's primarily for the gateway developer community. If you just want to use a gateway, you can use SciGaP. I would recommend using SciGaP. And let's see, let's have a chat question. So Mona asked, how does this compare with Globus in performance and size? And so Dimuthu or Suresh, one of you guys want to handle that one?
Yeah, Mona, yeah, that's a good question. So the short answer is for large data transfers, obviously, like Globus is a great solution, and we try to use that. And then also for campuses, like we are integrating with Georgia Tech and Georgia State and so on, where there are Globus subscriptions, we'd like to heavily leverage and use and build over Globus. So the MFT solution, what Marlon was presenting, is an open source alternative. So the non-technical piece of the answer is the Airavata being an open source project, an Apache Software Foundation project, all the dependencies have to be Apache license compliant. So GPL components are not allowed. Likewise, our closed source project. So we always have been exploring in the open source world, what other alternative MFT solutions exist. we've looked into solutions like Nextcloud and few others. Like we couldn't find a good open source dependency where we can assure everyone who downloads Airavata will get a free access kind of a open source bundle. So MFT, like where it uses is for the small data sets and for multi protocols between clouds and so on. And the performance part is a good question. We haven't come to that. I don't think so. Like now we will like to compare head to head and say MFT is better than Globus because they solve different purposes. But for certain things we will have to, and that's coming in the future. Yeah, there was a comment, some another comment, I guess.
Okay, thanks, Suresh. Here's another one on chat.
Yeah, Chunham.
Yeah, Chunham. Yeah, that's so.
You want to read the question first, just so everyone knows? So, Pat, about the app. Yeah, go ahead.
Yeah, thanks, Kathleen. So, Marlon, if you can rewind back to the Custos slide for a minute.
The Custos slide?
Yeah, the Custos one. So.
The question from Chunhan is Apache Airavata provides REST API similar with a Gavi API?
Yeah, Marlon, the Custos are internal. Yeah. So, yeah, Chunhan, that's a good question again. Like, as Marlon was trying to say, what we believed in, like, which we've been using in the last 10, 15 years is protocols like the Apache Thrift, Avro, or Google Protobuf, or gRPC. Like these things, in some sense, predates REST, or they've been traveling along REST where they provide SDKs directly. But like, as we've been increasingly, like, as Custos and MFT are already moving to gRPC. So when we move to gRPC, they have an inbuilt, like, not inbuilt, a proxy service which will provide REST APIs. So to direct answer the question is, Airavata today only provides Thrift-based SDKs, and in the future, as we move to gRPC and Protobuf, you'll see a figure like what you're seeing in this Custos diagram, where there'll be a gRPC endpoint always, but you'll also have these REST bridges, and if for a reason, if you have particular with REST, you could use those bridges.
Yeah, if I could quickly also go back here. So the general approach is there's an API server today, and that is the API is defined with Thrift interface definition language, which we have a paper about from 6 years ago, maybe now, about what the key features of that API, what it looks like, and also all that current API is under all the interface definitions are all part of our part of the Airavata GitHub repository. So Thrift has some nice features. You can define exceptions. You can define your data types. You can have some strong typing. I think one interesting thing we found was backward and forward compatibility worked really well. I won't go into that anecdote, but let's just say we found out to our pleasant surprise that it did. So that's the current state. Just to reiterate what Suresh was saying, also, but the plane's flying, and we're also working on it at the same time. And we, there's some newer approaches that have some interesting potential advantages over our current approach that we want to keep looking at. Let's see.
Another question came up from Julian Chastain. Oh, sorry, nope, that was not the one that I was moved up so quickly. Sorry, from Jack Smith asking, is Thrift similar to Open API? And he put in parentheses Swagger.
This Suresh. So Jack, I think the Thrift has an overlapping thing with Open API. So the similarity ends where Open API can also generate SDKs, but Thrift has a few other good advantages, like it creates APIs forward and backward compatible. Like in some of the clients, what Marlon was showing there, we had an Ultrascan, a client to SciGaP infrastructure didn't have to upgrade for quite a few versions, like of their clients. And then so basically a client can, a gateway can have an older version of an API client and it will be compatible with a newer version of an API server. And the reverse is possible as well. And a newer version of a client can talk to an older version of a server. So there are more things like with gRPC and Thrift provides, but they also do provide what OpenAPI does, which is the auto-generated SDKs.
Okay. I have a couple more slides, but any other questions, or then we can wrap it up and open
there
it
are
up?
no other questions other than when the slides will be, a recording will be available, which will be, I'm sure, by tomorrow. So carry on.
Yeah, and I'm happy to bundle these up as a PDF and send out prior to that as well. Okay, so I'll just start from the beginning here of the slide. So it's open source. Airavata is open source, open community. Everything that you saw here is in GitHub. It's Apache software license. Apache Airavata itself is regularly released to the Apache Software Foundation, which is not a trivial thing to do. CIRC, our team at IU runs Airavata. We don't own Airavata. That's a ASF project, but we run a hosted version of it for clients. We integrate important, I think, capability of Airavata is we integrate campus clusters, Exceed resources, computational clouds, and international resources for our gateway clients. So a gateway doesn't need stuff installed in a particular place. If you have a gateway and you have your own private, interesting collection of resources, we can hook all that up into the platform, or you can configure it through your administrative interface. We use best of breed software subsystems wherever we can, Keycloak and Vault, and the CI logon service and other types of other projects. Helix, I mentioned, a few others. We don't feel like we need to own the entire stack. And then the subsystems for security and data management are evolving such that we can start to think about Airavata as, it is decoupable subsystems, where if you really want a certain part of it for your gateway, then that can be supported. And I see several chat messages have popped up, so I'll.
Oh, no, well, it was just about the PDF, but there is a question from Danuka. Are there clients using the Django Portal REST API directly?
Marcus, you want to answer that one?
Yeah, no, I don't think there are any clients that are using the Django Portal REST API, outside of the portal. There are custom Django apps that use the JavaScript API within the portal to access the REST API. But we could potentially make that work. Right now, the authentication is session-based. So you have to log into the Django portal to be able to use the REST API. But we could, use some sort of like token-based authentication instead, and then you could use it from clients outside the portal.
Okay.
Great. We have about 1 more minute, and I don't know if more questions are coming, but we should, yeah, well, that's a good thing to post for additional information. Go ahead, Marlon.
Yeah, this is the last slide. Yeah, so basically you can contact us and you can try out a turnkey gateway by applying through SciGaP.org. If you want a customized gateway, I think the simplest, you can always write us in a proposal, as some people do, but the simplest way to get going is either through extended developer support through SGCI, or get an exceed allocation and request extended collaborative support services. And everything is, so we have done extensive documentation at airavata.read2docs.io and other links for other services, like especially Django has extensive documentation. The others are newer projects, but we're actively getting those into projects and into production usage. We're not just here to write software, but we're here to run systems that support science. And so all these things are, it's important for us to know that the software is documented, running well, and usable. So I'll stop, and it looks like we have some more chat messages and questions. So I think probably a good time to open it up for more questions.
Yeah, we can certainly stay on a little longer for those who want to stay. I will, when you stop sharing your screen, I will also let everyone know about next month's webinar. So here, I'll stop. There we go. So I'm just going to let you see real quick what is happening coming up. So you should be able to, oh no, wait, let's see here. Are you, I hope you can see my screen. What I wanted to let you know is that we have number 4 of the series coming next month on May 13th. It will be actually, I'm getting that backwards. In June, we will have part 4 of our Gateway Platform series about Galaxy, but next month is a brief break from the theme of Gateway Platforms, which is about enabling your research community and getting people engaged in your gateway. So that will be presented by Dave Clements of Galaxy Training and Outreach, who has very successfully gotten many people involved with Galaxy. I just wanted to also point out we have all these various things and deadlines coming up. So, and the link to our webinar archive is up at the top of this slide and in chat as well. So those slides will be posted almost certainly by tomorrow, sometime tomorrow. Do just go ahead there and you'll find both the slides and the recording. So, Marlon, I'll let you keep on talking though. Go ahead and answer other questions if you want. I know there was one quick question about database per microservice, but it sounds like Suresh is going to reach out to Arjun, who asked about that, and he posted a blog post explaining that. So is there anything else that you wanted to share, Marlon? And we'll see if any other questions come through.
Yeah, before that, Jack Smith had a question about integrating with Jupyter Notebooks.
Mm-hmm.
Yeah, Marcus or Suresh, you want to say something there? I think that was in regards to the Django REST API.
Marcus, you want to start with what you have?
Yeah, I think that would definitely be a use case for using the Django REST API from Jupyter. We also have a Python SDK that's been developed that I think would be an alternate way of interacting with the Airavata API from within the Jupyter Notebook.
Yeah, that's a good broad question. I think there are pieces of it. For example, the Custos has certain capabilities which we would like to integrate with Jupyter Notebooks with, as a reverse contribution to, so that projects which are building upon Jupyter Hub and Jupyter Notebook could benefit with more federated authentication, authorizations, and so on. And likewise, the reverse, where we would like to integrate Jupyter Notebooks into Airavata infrastructure so that would interact. But we try to, Apache Airavata as an open source project is very user driven and use case driven. We have seen these kind of use cases mushroom up, but we haven't seen something really tangible to latch on in a production level one. But we have some in the pipeline coming. But if you're have any concrete interest on, I would like to use Airavata based gateway, and here is my use case with Jupyter, we're allowed to entertain that.
Terrific. I think I haven't seen any more questions come in, so I think with that, I'll thank Marlon and Suresh and Marcus very much for pulling this together and being available. We had a great turnout, and I'm glad to see so many people could benefit from hearing all about this, and that was really clear enough that even I understood what was going on. So thank you very much for that.
Great. You're welcome. Thanks everybody for